As that liquid water absorbs thermal energy at 100 degrees centigrade, 212 Fahrenheit, it becomes steam and expands 1,600 times. The heart of the thermal energy storage and conversion system is a programmable, environmentally friendly synthetic phase change material. So essentially, we can program the freeze melt or vapor points anywhere from minus 40 to 450 degrees Fahrenheit, and we can go higher.
Today on the show, we have Michael Logan. His company is called MP Logan, and they're the master distributor for the NovaCap thermal energy storage and conversion system. So, Michael, this is some really interesting technology, and I'd love for you to tell us what it's all about.
Sure, sure. Well, a little bit of background. I have been in renewable energy sustainable development since the early 2000s, and I was on the board of directors and vice president of the Renewable Energy Institute. So I've seen dozens of technologies. When I was introduced to this in 2016, I had my chief engineer, who is an Annapolis grad, retired United States Navy commander, master's in mechanical engineering, you know what that's about. Top 1% of NASA engineers as voted by his peers. He was my chief engineer. I had him go check it out. And if you've ever worked with the military, you know when they give you short answers, you can rely on them. He said, it does exactly what they say. Nobody else in the world has it. I was sold. It was like finding a pearl of great price. I sold everything I had to go buy the field. So a little bit about what it does. Let's start at the macro. The macro is we spend globally in all of its iterations on energy, in all of its iterations, about $6 trillion a year. We successfully waste over $3 trillion of that. Most of it is wasted as thermal energy. Now, that's Charlotte in the background. How this came about is Dr. Stefan Bilodeau, the inventor, who, by the way, is a consultant to the United Nations on climate-related issues and is helping to resolve the severe energy shortage in Europe as a result of the Russia-Ukraine war. But he was running an engine manufacturing line for General Motors. And in the process of that, think about an internal combustion engine. Most of the engine is there to contain the explosions that are happening in the cylinders. So a tremendous amount of heat. In fact, about 2/3 of every gallon of gasoline is wasted, and diesel fuel too, is wasted as thermal energy. That's how egregious it is. Okay, so as he looked at that, he began to think about what available solutions are there in nature. He didn't, and I think in his engineer brain, he did go to a special place. I'm not sure where that place was, but it wasn't how complicated to make it. In fact, for the first 2 years when I was learning about this, I complicated it and didn't understand it, but it's this simple. Ice, as it absorbs thermal energy at 0 degrees centigrade, 32 degrees Fahrenheit, it becomes liquid. As that liquid water absorbs thermal energy at 100 degrees centigrade, 212 Fahrenheit, it becomes steam and expands 1,600 times. The heart of the thermal energy storage and conversion system is a programmable, environmentally friendly synthetic phase change material. So essentially, we can program the freeze melt or vapor points anywhere from minus 40 to 450 degrees Fahrenheit, and we can go higher. But those are the ranges we work. Now, I'll tell you a little bit about how it works, but I want to tell you that this isn't just hot off the press. This was developed over 4 generations and deployed through Dr. Bilodeau's R&D company in Canada in 42 projects, 400 tests, zero system downtime. That's how reliable this is. So what happens is, whether it's a chiller in a building or boilers at the hospital or a pulverized coal power plant or a solar PV field, there is thermal energy that is not being managed. And what happens is you determine how you're going to get a fluid that contains that thermal energy into the test. So it's a plumbing issue. And once it's into the test, what's happening is the test can absorb up to 3.5 million BTUs per cycle. and its maximum output is 1 megawatt. So what's happening is it's a shipping container, and about 85% of the shipping container is filled with blocks of programmable ice that's programmed to become semi-liquid at the precise temperature of the fluid that's coming in. So it's basically going through coils, and as it's going through coils, it's inside of the system. It's becoming semi-liquid. Now, about 12% of the balance of that shipping container is an enclosed turbine. Now, the turbine doesn't have to deal with that explosive steam pressure. So we're talking about low pressure turbines that are set, and there's a liquid synthetic phase change material in there that becomes vapor at the flash point. It spins the turbine, generates the electricity. And then the rest of the unit is an artificial intelligence controller that allows it to communicate with the building and or the power plant or the factory or whatever. So that's kind of a little bit of a rundown. It's a battery, but we're not storing electrons. We're storing thermal energy, which means we can store it much more densely. And I'll kind of kick it back to you and see where you want to go from here.
Yeah. So what are the applications for this?
Good
this
question.
product?
Dr. Bilodeau's R&D company. I'll tell you who we just shipped to in the United States in March. These were the first two shipments in the U.S. One was an investment company in New York called BlackRock, and the other one was Southern California Edison. These are essentially what are called TIM, technology integration models. And what we're doing here is seeing how well can we play together in the sandbox before we buy a gazillion of these things. So one of those is data centers. There was I think one of the generation 3, 4 installations in Canada was the Montreal Stock Exchange Tower. What we did there is we caused the 700-ton chillers to perform like 1,200-ton chillers. We created 700 megawatt hours of electricity that they wouldn't have had otherwise. We caught that off the chillers, and then for the data centers, and there are 2 floors of data centers, we caught the heat off of the servers. So this is really cool. This is like, you got to really know what you're talking about. So the acid test came when they said, okay, we're going to see if your stuff really works. So on a Saturday night, since the stock exchange is closed on Saturday, they turned off the power 6 blocks around the tower. In less than 2 seconds, tests had the tower up and running, and the data centers didn't even know that it had lost power. And again, we would be able to provide 6 hours of uninterrupted power while either natural gas generators or the grid is repaired or whatever happens. Another couple of applications, we're looking at one right now, which is amazingly exciting. If you look on the internet for concentrated solar troughs, they've been around forever. They focus the thermal energy of the sun. They're capable, the one we're talking to right now, can in a day's time generate 10 million BTUs of power. Let me tell you how that breaks down. All right, so as we take that into the tests, we could literally cycle the tests 3 to 4 times a day with that heat, which means, and wait till you hear this, solar PV takes 7 to 12 acres. What I'm about to tell you takes 4,000 square feet. Are you hearing me? 4,000 square feet. So what's happening is we're going to test it. The TIM model goes out to California in July probably, and if we're really lucky, end of June. But what will happen is because it's a government contract, we have to prove that these two technologies will play well in the sandbox. So listen, with one of our boxes and one of their sections of parabolic solar trough, we could in a day's time generate 24 megawatt hours of electricity in a 4,000 square foot spot. That's an application. Another really cool one. Okay, imagine this. Imagine that you're the CEO of a refinery, and the board of directors comes to you and says to you, you need to become more ecologically friendly. You need to reduce your carbon footprint. Well, here's what we do. We go into the refinery. We capture the various places where they're essentially ejecting the heat up through cooling towers. we use that heat as fuel, we reduce their grid dependence by about 20%. And this is particularly important. We're looking at several in the Houston area right now. This is particularly important in Texas because this could become the shock absorber that prevents the grid from being disrupted when a hurricane comes in from the south or an Arctic front comes in from the north. And I'm telling you, there's not a vertical market that we couldn't fit. And I'm going to blow your mind with this. All right. We filed a patent. MP Logan Associates has filed a patent for a put it anywhere in the world EV charging station. I mean, anywhere in the world using that technology, a much smaller version. We only need about 100 kW storage, but you would be able to pull up in the middle of the Mojave Desert and plug in your EV and charge up. And I'm going to take you. Did you ever watch The Twilight Zone?
Oh yeah.
Okay, I'm going to take you into the Twilight Zone. We think it's going to be possible to put together a mobile vehicle that doesn't need to pull into a charging station. It will charge while it's going down the road. I think we're a couple of years away from it, but that's kind of where we are. Anyway, back to you. I'm excited about this in case you can't tell.
So let's say the EV station in the Mojave Desert. So that's just absorbing the heat from the environment, and that's why it's constantly.
What's happening is that you've got this parabolic solar trough. I use the Mojave Desert as put it in the middle of the wilderness, except don't make it the North or South Pole because then we lose the sun. But what we're doing is that if you look at the parabolic solar trough, it's literally focusing the heat of the sun on the conduit for this liquid. And so it's constantly charging. That's constantly, and even the pump is being powered by solar energy. So you're pumping that through the test unit. You pull up to the test unit. Maybe you're in the middle of the Allegheny forest. I don't know. You pull up to the test unit, put in your debit card, plug it in. We can store. Average car charge is about 7.5 kilowatts, and we could have at the ready 25 kilowatts anytime somebody wants to pull up, and probably even more than that. So we see this as a potential game changer. And I want you to think about this. If we got this around the world, deployed around the world, we got into all the vertical markets, we could reduce the global raw energy consumption by a third. And at the same time, with all of the existing power infrastructure, we could increase the power output by 25 to 40%. That's the significance of this technology.
You said, how many years ago did he develop the technology?
Started in the early 2000s. He came up with the idea, and he won an international ASHRAE, ASHRAE, you can look it up, you're probably familiar with it, award, Excellence in Engineering. That was picked up by the Canadian government. They tried him out in Transport Canada using refrigerated frozen transport, where we had some glitchy things because it was moving down the road. It's a lot better stationary. We've resolved those glitchy things in the ensuing generations, but we reduced their fuel consumption by 25% because we were catching the heat off of the radiator, charging the test unit. The driver gets tired at the end of the night. He turns off the truck, cycles on the test, keeps the cold stuff cold, the frozen stuff frozen, and provides electricity to the cab. That's where the savings was. And then Environment Canada, they did a couple of buildings for them, reducing energy consumption by, again, about 30%.
Is there a competing product out there that's even close to this technology?
Not right now. Not right now.
Yeah.
This is like I was sitting down and I got a hold of the magic lamp and said, I want a technology that nobody else in the world has. And I was kind of sort of looking for it. And I have some pretty neat stuff that I'm working with. but what I see here is a technology that's attractive two ways. It's attractive because it immediately increases the profitability wherever we go. And I didn't mention this to you, but if you cycle it 15,000 times, that's about 40 years. It'll still be 85% as efficient as when you first bought it 41 years ago. Okay.
Wow.
And so you can put a modular upcharge on it. It's not like Tesla where you got every 7 years, check, need some more, check, need some more, check, need some more. This stuff does stuff. In fact, we can make Tesla work better. If Elon, if you're listening, give me a call. We'll figure it out. And Chad would like to know if
Yeah.
you're listening too. So
Yeah, definitely would. Yeah, because those batteries, I mean, yes, you're not running a gas engine, but the production of the batteries for the EVs, you're putting a lot of resources into producing them, and then if you have to scrap them and put new ones in, it's very
right,
wasteful. Whereas this,
right,
if you're saying what you have 41 years and it's still working at 85% capacity,
right, right. So
yeah.
and here's where we are now. Understand, in order to get the market and be able to build the brand and get out there, so that when people think about thermal energy storage and they think about conversion of thermal energy, it's like the Energizer Bunny or Tesla, whose name you should pay us a little bit of advertising on that, Elon. Just saying. But it'll build the brand, and we need to build the brand in order to be out there and get the most good out. Because here's the thing. We're looking, I don't care what side of the fence you're on, if we're seeing a consistent increase in atmospheric and ocean temperatures, who's responsible for that? It's us. So just be responsible stewards, do the right thing, stop wasting half to two. I didn't tell you this. Every building in the world, from the smallest tiny home to the Burj Khalifa in the Middle East, wastes half to 2/3 of the energy they buy. Most of it's wasted as thermal energy. We can fix that. That's the power of this technology.
So, Michael, if somebody in our audience wanted to reach out to you to learn more or have this technology installed in a major commercial application, how would they do so?
You can find us our website is www.mplogan.co, and just hit us up there. Send us a note of interest. And also, if you're interested and you'd like to know more, we have some recorded webinars that Dr. Bilodeau did. And while we usually charge for making those available for anybody in Chad's audience that would like to listen to those webinars, Chad, I'll make those available to you guys.
Well, thank you, Michael, for doing that. And also thank you for being on the show. Thanks, everybody, for listening to another episode of Failing to Success. I'm your host, Chad Kalecki with Cosmic Design Development. Make sure to like, comment, and subscribe, and we'll see you next time.